Hi, my dear students. Welcome you all. Welcome to Unacademy. Welcome to the Dakshina Engineer Junction, where you will get the complete knowledge required for the GATE as well as other competitive exams for free. And if you want any other specific topic you need, so here all of you do comment in the comment section. We are ready to provide the best content. Fine, let's continue our discussions. And before this, we have one great offer from Unacademy, the 15 months plus subscriptions. So you will get with just easy electrical 44,000. In addition to that, and if you apply the code of BV Reddy by using a code of BV Reddy, you will get the additional discount of 10% discount. You will get it. Additionally, 10% discount you will get. So what are you waiting? So all of you do enroll for it before the October 30th. And one more thing is, by taking 15 month subscription, you will get additionally 1 month subscription completely free. 1 month additionally you will get free. Try to utilize this opportunity before it going to expire. And iconic if you need, so it is a 59,000 near. And even you can take this Unacademy subscription with no cost EMI also. And these are the new batches we are starting to for your encouragement and all. You can get the best educators in the single panel. These are the benefits of Brahmastra Plus. And if you want to enroll for this, you can use a code of BV Reddy. By using this code of BV Reddy, you will get the additionally 10% discount. You will get right. Fine. And so, as you know, here we are very near to the gate. So try to utilize this opportunity. So we have a 6 months subscription also we have. And the students who has taken the Unacademy iconic subscription, they will get the physical notes. For that, you need to upload your proper address and contact number properly to dispatch the physical notes. And the benefits of Unacademy plus the top educators and digital notes and test series. For iconic, students will get additional benefits of customized doubt solving, printed notes, one-to-one mentorship, strategy and study program, interactive open house sessions. These are the benefits of the plus and iconics. So let us coming to the today's topic and all. As we are in the previous classes, we have discussed some of the topics, and let's continue our discussion. The last class we have done this consonance theorem. So here now today we are going to discuss some more topics. We are going to discuss the next topic will coming to here, Boolean function representations. Let us talk about the Boolean function representation. The Boolean function can be represented by using two different ways. One is canonical form. The other one is minimal form. One is canonical form. The other one is minimal form. Let us see what is meant by canonical form and what is meant by minimal form. See this thing here. For example, if we consider some Boolean function, let us say it has contains three literals. Literal means here A, B, C. These variables are called as literals. So here how many literals are there? A, B, C. We have three literals are there. Have considered one Boolean function having three literals. Yes, these are called as literals. We have taken three literals, and if the expression which is of the form, let us consider here, it is A, B, C bar. I'm just considering here. That is A bar, B bar, C bar, and A, B, C. Let us consider we have like this form. A, B bar, C bar. Consider we have like this. So if you see carefully, now each term, this is one term, this is second term, this is the third term, and fourth term. We have four terms are there. In each term, we need to see whether we have all the literals are present or not. Here, how many literals we have taken? Now here, three literals we have taken. Each term, this contain three literals. This contain three literals. Either it is a normal form or complemented form. This also contains three literals. This also contains three literals. Then this type of expression, which I can call that as a canonical form. This form, which I can call this as a canonical form. This form, which I will call this as what? Canonical form. Isn't it? So if the expression any of the term is missing, then I can call that as a minimal form. If any term is missing, then we can call that as a minimal form. So if I have taken this as, let us consider the expression a comma b comma c, and which is equal to, consider we have a b, let us consider we have a b c, let us consider we have a c, consider we have like that. Now here how many literals we have taken actually here? How many literals we have considered here? Here we have considered three literals, but here this term contains only two literals. This term contains two literals, this term contains, if any of the term contains number of the total number of literals, then I can call that as a minimal form. Then we can call that as, what you tell me, minimal form. We are going to discuss about canonical form and minimal form here. Fine. Let's see. Canonical form means what now here? Each minterm. So here, if you see carefully, this term is there now. This term, which we wish to call this as a minterm. This term is called as a minterm. Yes, and this is another minterm. This is another minterm. This is another minterm. Each minterm contains all the possible combination, means all the literals are present now. Then we can call that as a canonical form. And here, if each minterm contains all the Boolean variables, means all the literals, then we can call that form is called as a canonical form. And here, for example, if we consider f of a, b, c, which is given as, now you tell me now here, if we have a, b, c, and a bar, b, c bar, and this is a, b bar, c, consider we have like this. Now you tell me what I should call this is now here. Each term contains in the all the terms. Each term, all the variables are present. Each minterm. So this is called as a canonical form. This is called as a canonical form. This form is called as a canonical form. And if the expression is of the form, which is in the form, here this each term in this a type of expression which is called as a SOP, means sum of product, and this term is called as one minterm. All these minterms we have arranged in the form of, what you tell me, product form. So that's why this is called as a sum of product. All the terms which are summed, all the product terms are summed. That's why this is called as a sum of product. Next, and here if we see, if the expression is of the form like this, a plus b plus c, or a bar plus b bar plus c bar, consider here we have a plus and b bar plus c, and here this term, each term in this form, this type of form, here what I did, you see, first we did the sum. First what I did, now here I did the sum, then after what I did, you tell me, I have producted, I have taken the product. First I did the sum, after that I did the product. That is, this is called as product of sum. Product of sum. So in short form, which we used to call this as POS. This form is called as POS. This is the product of sum. And each term, this is one term in the POS form now. This is another term and this is another term. Each term in the POS form is called as a max term. Each term in the POS form is called as, what you tell me, max term. Each term in the SOP form, which is called as a minterm. Each term, which we used to call it as a minterm. Each term in the POS form is called as a max term. Now you check this thing, is this max term contains all the literals or not? All the Boolean variables or not? Yes, it contains. So that's why this is called as a canonical form, and we can call this as a canonical POS form. Okay, canonical POS form. Is it fine to all of you? Tell me. Next. So the minimal form. Here, minimal form means the minimized form. Minimal form is the minimized form. Let us say we have the expression a plus b into b plus c into c plus a, if we have like this. Now what I should call this is the, here we have taken three variables, but we have this term. What I should call this term is that this form is called as a SOP form or POS form. First we did the sum we did. So here then we can call this as POS form now. POS form. So that means here we did the first sum and then product we did. That's why this is the POS form. Now you tell me, this term is called as max term, this term is a max term. And this max term, here we have A, B, C, but here C is missing now. So that's why this is not a canonical form. So this type of form is called as a minimal form. So this is called as, what we can say, minimal form of POS. And the same thing, let us consider we have the expression AB plus BC plus AC if we have. Then you tell me now what I should call this is SOP or POS now. This is a SOP form. So I will call this as a minimal SOP. This is called as a minimal SOP. Fine, all of you? Next one. Here these are the definitions if you know. What is literal means? A Boolean variable, whether it may be normal form or a complemented form, is called as a literal. Normal form or the complemented form is called as a literal. Means if we have f of a comma b comma c, which is in the form of, let us say here we have a b c plus this is a bar b bar c bar. Now you can see this thing, this it contains, now here how many literals you see this thing here? Here we have A, B, C. This contains how many literals now here? 3 literals contains. And this contains how many literals you see here? This contains another 3 literals will contains. Now let us say we have one more expression which we have. This is A, B, C bar. Now you tell me now how many literals are there? This term contains another 3 literals contains. Isn't it? Right. So whether it is a normal form or the complemented form is called as a literal. If we have the expression, let us say this is AC bar consider. Then you tell me how many literals are there here? The number of literals are 2. Okay, in this case. Minterm. What the minterm means? Each term in the SOP form is called as a minterm. Each term. What is the SOP form means what? SOP form means sum of the product. If the expression, what I need to do here? SOP form. That means sum of the product. Sum of the product. So you know the English. English is a reverse language. English reverse operation. So here whatever we used to do this thing, that should be done at the last. Last should be done first. Here this is. Now here first. What is this operation? Product. Product should be done first. We need to move like this manner. So which is the expression which we can say this as ABC. First what I did now? ABC product. Thereafter I did A bar, B, C bar. Thereafter I did, so this is A, B, C bar. This is called as a SOP expression. Product. After finding the product of this thing, we did the sum I did. Yes or no? First this product we need to find. After that we need to find the addition, sum of these two. So here this is called as a one minterm here. This term is called as a one minterm. And this is another minterm and this is another minterm. How many minterms this expression will contain? 3 minterms contains. Next. Maxterm. Right. So if the expression which of the form, as you might understand about the English language, you need to do the reverse operation. If we have f of ABC which is of the form which is equal to, let us say we have A plus B plus C and A plus B bar plus C bar and A plus B bar plus C. Consider we have like this. Now here you see this thing. Here what I did now, first addition, sum I did. After that we have taken the product between these two. So that's why what I need to write now, first what I did, you tell me. I did a sum. That should be written in the last now here. And so last what I did now, product I did. So that's why this is called as a product of sum. So we'll simply call this as a POS. This expression which is called as what, you tell me? POS form. And what else you see this thing here? Each term in the POS form is called as what? Maxterm. Each term in the POS form which is called as what? Maxterm. Here this is one maxterm, this is one maxterm, this is one maxterm. So totally how many maxterms are there, you tell me? We have 3 maxterms are there. Isn't it? Right. Next, let us understand this concept of minterms and this maxterms in detailed manner. SOP form and POS form. Let us consider we have some digital system we have. This digital system we don't know about what is the internal operation of this digital system. I'm just considering the internal operations to understand the concept of SOP form, POS form, minterm and max terms. Okay, let us see this thing. We have taken three inputs now. A, B, C are the three inputs and Y is one output. Now you see this thing. What are the possible combinations? You see this thing here. A. A can take either 0 or 1. What about the B? B also can take 0 or 1. C also can take either 0 or 1. These are the possible combinations, right? Next. Now you see this thing here. A. If you see carefully. And here I will take this A value 0, B value 0, C value 0. This is one combination. And A value 0, B value 0, C value 1. Let us just take, we will take this is another combination 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. These are the possible combinations. Now tell me. Now let us see how the output is now here. The output here, since we don't know what is the internal combinations, and I'm just considering some random output. And if you see this thing here, how many combinations are possible? You tell me now here. 1, 2, 3, 4, 5, 6, 7, 8. 8 combination. How many variables we have taken? You know. So we have taken 3 variables. That's why how many combinations I formed here? Here we formed the 8 combination we have formed, isn't it? So in that manner, what we can say now, if we have 2 combinations are there, 2 variables are there, how many combinations are possible? You tell me now here. We can form 4 combinations, isn't it? Right. If we have a 3, I can forward this as what you tell me now 8 combinations. Now in the same thing we can extend for 4. I can able to form the 16 combinations. That means if we have n combinations, n variables are there, how many combinations we can able to form? You see this thing here, 2 power n combinations I can form. How many combinations I can able to form? 2 power n combination I can able to form. The total number of possible combinations for the n variable case, how many you tell me now here? Will form the 2 power n combinations I can form. Everybody? Now coming to here, let us see the output. Output, what happens? So we don't know the output of the system. Just consider we have some randomly we have taken some output. We are just considering randomly some output we have considered here. We have taken, assuming this is 1, and just taking some to understand this concept of SOP form, POS form. 1, just consider here 0, 1, 1, 0, 1, 0 and 1. I have taken as like this. Why I have taken means there is no reason. I just taken some example. If you want, you can take some other and we'll analyze it. I have taken this as an example. I want to analyze it now. Isn't it? All of you tell me. This point clear? Tell me everybody. Now let's see this thing here. I want to analyze this SOP form, that is sum of the product. In sum of the product, so if it is a logic 1, in logic 1 which is called as a normal form of a variable. If A is a variable, we can take normal form, logic 1 means. And logic 0 means which is the complemented form. Logic 1 means normal form and logic 0 means complemented form. Okay, in the SOP form. Look at now here. So in this case we have a variables here. In case of a logic 1, so how we need to write the expression we need to see. In case of SOP form, we need to concentrate on where the output is 1. Where the output is 1, you see this thing here. In this case output is 1. 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 In this case is output is 1. That is 1 means high. Now in this particular case output is 1, then I can write the expression where y is the output, which depends upon what you tell me now here, a comma b comma c, and when the output is 1, you see this thing here, when a equal to 0, b equal to 0 and c equal to 0. 0 means how we need to write here, logic 0 means we should write a bar. So means what I can say, this is a bar, b bar, c bar. Next, this is the SOP from the product of that sum. And what the next term here, when the output is 1 here in this case. You see this thing here, a value 0, b value 1 and c value 0. Then how we can write, you tell me now here, which is equal to a bar, b, c bar, isn't it, plus sum of the product. And tell me the next term when the output is 1. In this case also output is 1 now. So a value 0, b, c are 1. A value 0 mean that is a bar, b, c are 1. Next, here in this case also 1. So 1, 0, 1. A value 1, b value 0, c value 1, plus next here all one case also output is 1. So a value 1, b value 1, c value 1. This is called as a SOP expression. And if you see carefully now here, this SOP, each term in the SOP form, which we can call this as, what you tell me now, these are called as a minterms now. These are called as a minterms. So what are the minterms, you see carefully now here, these are called as a minterm expressions. Then this expression, which we can also write this thing as since this is SOP form, we can write sigma and small m. Now here can you tell me now here a value 0, b value 0, c value 0, isn't it? A bar means 0 now here, 0, b is 1, c value 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. You tell me how we can write now sigma m. So these terms are what you tell me now, 0 now corresponding decimal equivalent of this binary number, and this number which is equal to 2, and this value which is equal to 3, and this value which is a 5, and this value is a 7. Now this expression which we can write it as y of a, b, c, and which is equal to minterms, since it is, we can indicate it as small m with m naught, plus sigma na here, that is m2 and m3 plus m5 plus m7. m0, m2, m3, m5, m7. These are the terms. Done all of you? This is SOP form expressions. I hope everybody clear, I think so. Done? Now the next we are going to see the POS expression. How we will develop the POS form. Now here the POS form, the output y, which depends upon what you tell me now here, a, B, C. Right. And here in case of POS form, so we have logic 1, which will indicate it as a bar. Logic 1 is a bar. Logic 0, which is given as what you tell me now here, a, opposite to the previous one, you see. Done. Now you see this thing here, this expression y of a comma b comma c. Now you can see carefully in which cases output is 0. Here we should focus where the output is 0. Which case now? In this case output is 0. For what you tell me now here, a value 0, b value 0, c value 1. That means a value 0, b value 0, c value 1, output is 0. Here you see what you need to see carefully. A value 0 means in the POS form now, so that how to write now, this is a we should treat. This will be is a. And this is what you tell me now, b. This is what now, 1 means c bar. 1 means what you tell me, that is a c bar. Now you see this thing, what we can say the POS form. POS form means what now? First we need to do the sum, after that product we should do. First we need to do the sum, after the product we need to do now, that is what I can say, a plus b plus c bar. A plus b plus c bar. All of you tell me. Into, that is product. Now first we did the sum of the terms after the product terms. Next you see this thing here, the output is 0 now here. For what now here? 1 0 0. Tell me how I should write, you tell me. 1 means what I can say now, this is a bar. 0 means what we can say, b. And 0 means that is a c. Right. Now you see this thing here. In this case also 1 1 0. 1 1 0. Tell me here. 1 means what we can say, a bar. 1 1 1 0 means that is a c. Now tell me all of you. In this manner we need to write. This is called as a POS form. Here you can see each term contains all the literals or not. So this is, and here this is, each term is called as what you tell me now here, max term. Each term here is called as a max term. This max terms will denote with a letter of capital M. So now you tell me now how I can write now, this is y of a comma b comma c, which is given as, since this is the product now, that's why pi we can indicate. Pi of capital M. Pi of capital M into here, what are the terms here? So a means what now here, that is, a means what now here is a 0. This is 0 and this is 1. Here a bar means 1, 0, 0. And this is 1, 1, 0. And can you tell me this term which is called as a 1, and this is called is a 4, and this is a 6. Okay. Now this expression which we can write, y of a comma b comma c, which is given as, which we can also write, previously it is an addition. Since those are the min terms, here the product of POS form, it is a product we can write. So this is M1. This we can write as M4. And this is what we can say, M6. These are M1, M4, M6. Is it fine to all of you, tell me? These are the basics understanding of these Boolean functions. Done? Let's see the next one. And if you see here carefully, the maximum possible minterms. Can you tell me maximum possible minterms for in case of n variable? N variable. For example, if we have taken for two variable case, I have taken A, B we have taken, and this Y is my output. Now the input combination 0, 0, 0, 1, 1, 0, 1, 1 we can take now. I hope all of you know this thing. Now you tell me now here. I need the maximum possible minterms. That means what now here? So if I take this is minterm, this is minterm, this is minterm, this is minterm. So you tell me now here how many maximum possible minterms I can able to form it. You tell me the maximum possible. Maximum possible means if this is minterm, this is also possible to be minterm now. If it is all possible to be minterm, then how many now here? In this case we have a 4. That means which we can say 2 square I can write now. The here in case of 3 variable all are minterms only. The maximum I can say n variable case, how many I can say, tell me? That is 2 power n. That is how many you tell me? 2 power n. Now you tell me maximum possible max terms. Means all are max terms only. If I have taken these terms, you see this thing here, I want to make all are max terms only. I will take all are 0, 0, 0, 0. Then what I can say now, this is a max term, this is a max term, this also max term, these are the max term. These many maximum I can take now. These many maximum I can take. Yes or no? Tell me, yeah. So here how many maximum I can say? In this case also 2 power n only. In this case also 2 power n only. Isn't it? No. Try to understand here. Maximum, all will be a max terms only. All will be, if I take all max terms, so then it is maximum. And all are min terms. And can you tell me sum of number of minterms plus number of max terms, how many? Number of minterms plus number of max terms. So if you see carefully, in this case how many max terms are? We have 4 max terms and 0 minterms. And if we have taken this thing here A, B, C and Y, so this is 0, 0, 0, 1, 1, 0, 1, 1. Let us consider I have taken this as 1, 1, 1, 1. How many minterms here? Here max terms are 0, minterms are 4. Sum of this is how much you tell me now? 4 now. If we have taken some other case A, B, C and Y, let us consider here we have taken input 0, 0, 0, 1, 1, 0, 1, 1 I have taken. Now if you see carefully, if I say this is 0, this is 1, 0, 1. So tell me how many minterms are there? 2. How many max terms are there? Another 2. So the total number, how many you see this thing? 4. The sum of minterms plus max terms are how many you see? 4. That means that is nothing but I can say 2 square I can say now. In all the cases that is nothing but 2 square only. So the sum of minterm plus sum of max terms are how many for n variable case? That is a 2 power n only. The total sum of minterm plus total sum of max terms is how many here? Here, which is equal to 2 power n only. Next, the sum of all maximum possible minterms. The sum of all maximum possible minterms means, for example, if we have taken a 2 variable case, we have taken, consider 2 variable case now A, B, and that is for easy understanding purpose we have taken 2 variable. So you tell me now here that is 0, 0, 0, 1, 1, 0, 1, 1. The maximum, all maximum possible means all must be a minterms only now. Right. So you tell me now how we can write this minterms, you see carefully. This is a minterm. So how we can write now here? This is A bar B bar plus this is also minterm only na. This is A bar B and this is also minterm only na. A B bar plus this is also minterm only na. A B. Can you tell me sum of these two here? By combining these two here we'll get A bar. By combining these two here what I'll get now? A. So which is equal to what you tell me now? 1. Which is equal to 1. Isn't it? The sum of all possible maximum possible terms are how many? So that means what we can say, if we have a all minterms only, that is 0 is a minterm, 1 is a minterm, 2 is a minterm, 3 is also minterm. So what is the sum of all this? You can say now here this is m0 plus m1 plus m2 plus m3. So how much this value which is equal to 1? So in mathematically how we can write now here? Sigma n is from where to where? 0 to 3. 3 I can write as 4 minus 1, isn't it? Into, I can say here, I am taking the variable. So this is, let us say I is from 0 to f4 minus 1, mi, which is equal to, I can say 1. In generalized manner, what I can write, you tell me now here, sigma. So that is I is from 0 to, I can say total is 2 power n minus 1 na. 2 power n means 4. 4 minus 1, 3 na here, 3 only this thing. Into what I can say mi, which is equal to 1. Tell me this thing all of you. This is the generalized expressions. To power n. Done. Now let's see the next property. The product of all possible max terms. Can you tell me the product of all possible max terms are? How much it is? All possible max terms. So means what we can say now, let us say here two variable here. Next 0 0 0 1 1 0 1 1. And you see this thing here. Let us say to make this as maximum max terms I need, so I am making a maximum max terms. So in this case you see this thing, what are the max terms, you tell me now here. All are max terms only now. How we can write now? 0 is a max term, 1 is a max term, 2 is a max term, 3 is also max terms. Then so how we can write now here? 0. How we can write now? Tell me now in terms of max term means what now here? POS form, that is A plus B, isn't it? Next 1. So how we can write now? This is A plus B bar, and C A bar plus B, and D A bar plus B bar. And now you can see now, let's try to simplify this thing here. Now for these two, can you apply T1 steps? I hope all of you remember the T1 steps. That is what you tell me now, 1 3 2 4. Tell me now here, which is equal to A plus B into B bar, which is a 0. Next for these two also I can apply the T1 now here, which is given as A bar into A bar is A bar, B into B bar is 0. So what I will get to tell me now? 0. So here you see this thing, the product of all max terms. The product of all max terms. How we can write now here? That is product. That is M0, capital M na max term means, and then M1 and M2 and then M3. The product of all max terms is how much, you tell me now? 1. This is the product of all max terms. Sorry, this is 0. Sorry, what is the product of all max terms are? Which is equal to 0. Then how we can write this thing here? Sorry, here we have what we have, summation or product here. Here we have product. If I take I is from 0 to, I can write the 4 minus 1. Tell me what I can write now here, mi, which is equal to what now here, 0. In mathematically generalized manner, how we can write to tell me? That is product means pi symbol we use, pi. I is from 0 to 2 power n minus 1 and mi, which is equal to 0. The product of all max terms, which is equal to 1. Which is equal to 0. The product of all max terms, which is equal to 0. Next one, see the next property. Minterms and maxterms are of same index or complement to each other. Minterms and maxterms are of same index or what? Complement to each other. Means, for example, let us consider one minterm. Let us say here we have considered the minterm. Here we have taken this as m5. Let us say 3 variable. The number of variables we have taken as 3. You tell me how we can write the 5, you tell me. So the 5 in the binary form, which is equal to 1 0 1. Let us do SOP form we are doing. Minterm means SOP form. Now how we can write, to tell me? Which is equal to A, B bar and C. A, B bar and C. Now I am taking the, so this is m5, I have taken the complement of this. That means what you tell me now here, A, B bar, C whole bar. If you have taken the complement of this, what I will get, to tell me now, this is A bar plus B plus C bar. Tell me all of you. A bar plus B plus C bar. This thing here, if you see carefully, now how we can write the max term 5, you tell me? Max term 5, that is 1 0 1. So 1 means how we can write, to tell me now, which is equal to A bar, and the 0 means which we can write the B plus C bar. Now here if you see carefully, this is exactly same this thing, you see, isn't it? So from this what I can say now here, this is m5 minterm 5 complement, which is equal to what I will get now here, max term 5 I will get, and vice versa. Same index means here we have taken 5, here also 5. Now tell me now the same thing, if I have taken this as a m2 bar, which is equal to what we can say, this is capital M2, and if you have taken this as a m7 bar, can you tell me what I will get here? Which is nothing but minterm m7. And if you have taken this as a m100 bar, which is given as what we can say, minterm 100. Minterms and max terms are complement to each other of the same index, having the same index, right? Next, and what else you can see now here, in generalized manner, what I can say here, this is mi is one minterm, ith minterm. If I take the complement of this, what I will get, to tell me now here, capital Mi. All of you tell me. This is minterms and max terms are of same index or complement to each other. Next one, the product of two minterms of different index. Different index means what? Different values. Means here we have taken two minterms, I have taken. One is m1 and the other one is, let us say, m2 I have taken. I want to multiply these two here. So tell me now here, how we can write the m1, tell me minterm, let us say n is equal to 2. Two variables we have taken. How we can write, to tell me m1 means now, that is a bar b, what about the m2? Tell me now here, which is equal to ab bar. If we multiply these two here, tell me what happens now. m1 into m2, which I will get, what you tell me now, this is a bar b into ab bar, a bar b into ab bar. So you tell me this, what happens you? A bar b into ab bar. So a bar into a, which is equal to 0 now. That means the product of two minterms of a different index. Suffix are different, and this is 1, this is 2. Then what I will get, that is a 0. In generalized manner. Now if you see carefully, if I multiply this m2 with m2, what happens, you tell me same. That is what we can say, ab bar, if I multiply with ab bar only. So tell me what I will get now. This is simply ab bar only now. So in generalization, what I can write, you see this thing here, this is mi, if I multiply with mj. So what I will get, you tell me now here. If I equal to j, what happens? If I is not equal to j, what happens, you tell me. If I is equal to j, then I will get the same minterm will come now. If I and j are different, what I will get, you tell me now here, in that cases, which is a 0. If I and j's are different, the product of the different minterms is a 0. If it is same, we'll get the same minterms. Right? So this m2 into m2 is what you tell me now, m2 only. Isn't it? Product. Next. The sum of two arbitrary max terms. The sum of two arbitrary max terms are different index. Let's see this thing. Consider we have a max term, let us say 1, and consider max term 2. Two different max terms if you have taken. You tell me this is capital M1 means what, you tell me. So here assume this n is equal to 2, we have taken two variables only. How we can write now m1, which is equal to, this is 1. 1 we can write it as what, you tell me now here, that is 0 1. How we can write, you tell me now, this is a plus b bar we can write now. And the 2 means what, you tell me now, a bar plus b. Now if I add these two here, that is m1 plus m2, if I add sum of these two max terms, then I will get a plus b bar plus a bar plus b. Now you tell me this, if I add these two, this is a plus a bar, which is 1, and this b plus b bar, which is 1, which will get it as 1 now. That means m1 plus m2, the sum of two different max terms will come it as 1. Will come it as what? 1. Now if the sum of same max terms, what I will come, you tell me? Means if we added this as m2 plus m2, if I add, see what I will get, you tell me. M2 means what? A bar. M2 means what now here? Which is given as a bar plus b plus m2 means a bar plus b. So what I will get, you tell me now here, which is equal to a bar plus b only will come. That means what I can say here, m2 plus m2, the sum of two different max terms, which is nothing but m2 only. Tell me all of you. The sum of two different max terms, which will gives that 0, and sum of two different max terms, which is a same max term. So what I can write now in generalized manner, what I can say now here, this is mi plus mj, mi plus mj, which will gives, you tell me now here, which is equal to mi when I equal to j. And if I is not equal to j, what happen? I is not equal to j, this is 1, isn't it? These are the some of the very good points, very important points, so that you can solve the problems on this Boolean algebra. Right, all of you do revise all these properties and all. In the next class we'll solve some problems and we'll continue our discussions. That's for the today's class. We'll meet in the next class. Okay, all of you do like, share and comment in the comment section. If you need any doubts and all, you will discuss. And if you need any other particular topics you want, so do comment in the comment section. We are ready to help you in required topics. Fine. Okay then. We'll meet in the next session. See you. Bye bye.